today we are going to study Chapter 5, Section 2. Frequency tables, histograms, and frequency polygons. It does not get much more exciting than this if you're a math teacher. I'm joking. This is not the most exciting thing in my life, no. But it's very interesting. And you know what? We get to, like I said yesterday, we get to interpret data that we see in graphs and in different news publications and stuff like that. And you know what? If we're going to learn about something, or if we're going to make informed decisions about data that's out there, we need to be able to see it displayed in a way that we can quickly sort of process it, right? So if we think back to yesterday, or even if we look down here, look at that right there. Isn't that great? Look at that. Wow. Oh, wow. That's awesome. Now, wouldn't it be better if this data was organized in such a way that was a little bit easier to kind of glean some information out of it, right? Like, I mean, you know, you just look at this page of 100 numbers or whatever it is, and it's like, okay, I see some pink numbers there. That's good. What does that mean? Looks like a year and some other number. Okay, now you gotta look around. So I'm just going to fast forward here a little bit. Oh, that data is organized in a different way. Oh, look at that. Now we're getting somewhere. Isn't this much easier to actually process than this right here?
Yes.
This big mess of numbers right here?
Yes.
Okay? Now, it's important that we have the big mess of numbers, right? They got to come from somewhere. But the whole point of this is, let's take this big mess of numbers, let's organize it in such a way that we can glean some information out of it pretty quickly. We can actually process this and use that information, understand, learn from that information. So this is not as good as, let's say, a table. Now, I'm just going to back up a little bit because I kind of got ahead of myself. But anyways, look at this picture here. This is a picture of some massive flooding in the Red River Basin, okay, in Manitoba there. So it says flooding is a regular occurrence in the Red River Basin. During the second half of the 20th century, it's in the 1900s, or late 1900s, there have been 9 notable floods, 4 of which have been severe, occurring in 50, 79, 96, and 97. The flood that occurred in 97 was known as the flood of the century in Manitoba and in North Dakota. And I believe since the publication of this book, just a number of years ago, there was another notable flood just a few years ago in the same area. So it's fairly susceptible. So the following data, this big mess of data that I referred to earlier, represents the flow rates of the Red River from 50 to 99. So flow rates, and the units are cubic meters per second. So as this water moves through this river, what is the rate of the water, how fast it's coming, and how much it's coming. So how much is coming would be the cubic meters, and then how fast would be the per seconds. You see that? So it's kind of a volume over time. And so in 50, this one's highlighted, and we have 3,058 cubic meters a second. Compare that to 54, 524, right? Like almost a sixth of it. So we've got some pretty low numbers, but we also have some pretty high numbers. And of course, 1997 right here, the flood of the century, that's pretty big. Okay. Now, if those pink numbers, if it wasn't highlighted like that, might take you a while to sift through this and to try and figure out, just like yesterday when we had all those numbers about the battery lifespan and stuff like that. Might be hard to sort of get some information out of it. So the question here is, how can we approximate the water flow rate that is associated with serious flooding in Winnipeg? Well, again, how do we know when there's serious floods? We see some numbers here, but are there any patterns, and what number do we pick? How do we see what's going on? So the first thing that you've already kind of looked into a little bit is a frequency distribution. This is in the form of a table. Frequency means how often something happens, and the distribution is how often does the things happen over a span, right? So how often does this happen? How often does this different thing happen, and so on. So that table, and again, I'm not going to get you to do all this because I just want you to learn from it and think we can just see what the book is showing us and interpret it. We will practice this later. But this is a frequency table. So what they've done is several things. Okay. first of all, the first major thing is they have split the flow rates into 10 categories here. Okay? So the categories would be from 0 meters cubed to 500, then from 500 to 1,000. The process of choosing the intervals is something that we will go over, but just as an introduction, we have the whole range, right? We talked about range. We have that whole range split up into the intervals that are the same size. So that's really important. That's the first thing that's really important. The second thing is, as they went through this big mess of information that we referred to, as they kind of go through there, this is 3058. Okay, so they go to their table, and where's 3058? Okay, it's going to be in this one, you see? So they put 1 mark for that data point, 1 mark there. Then they go to the next one. What's the next one? They find the interval on the left, and they simply put a check mark or a little line or whatever. That's the tally part. And this kind of starts to disaggregate, starts to separate the information so that we can kind of see, oh, do you know what? The most common flow rate here is between 1,500 and 2,000. One might say that this is sort of the average flow rate. Well, it's pretty heavily weighted on the bottom here, so maybe that average is somewhere around here. But now, boom, you can look at this, you can quickly get some information, right? Yeah.
How bad is it when statistics are wrong?
How bad is it when statistics are wrong? Is that your question?
Yeah.
Okay, can you be a little more specific?
Well, it says 14 under 15 to 2,000. There's actually
14.
15 tallies.
There's actually 15 tallies. 1, 2, 3, 4, 5, 6. Yeah, I think this might be just kind of a typo error.
Oh, everybody.
This is supposed to be 5. This is supposed to be 5, and that is 4. So this is supposed to be 5, I think. Yeah. So if that's what you mean, yeah. So now the question is, okay, that's a good point. The question is, what's right, this tally or this number? Oh, mind blown. There. Okay. So, thank you. I don't know if I should make a note in my textbook here that is there, because that does look, it's definitely 15 there. But this should be a 5, because when you do this type of tallying, it's 4 lines, and then the 5th one crosses it out, so that you can look back and you say there's groups of 5, right? So yeah, that's supposed to be a group of 5. But thank you for pointing that out. So now what we might have to go back and do, if you did this, or if you noticed your neighbor do this, you would say, hey, is it 14 or 15? Because I see a number there, but I see your tally looks like there's 15. So then you'd have to go back and you'd have to double check, right? So which one is correct? Okay, that's a very good point. So as I was going to say next there, all of the flooding actually occurs from this point down. Okay, so it's this flow rate. These were floods, and this was a flood. So we can kind of clearly see that in this table, when it looks like we could say when the flow rate gets over 3,000 cubic meters a second, we're going to have a problem. And by looking at this set of data up here, you might not get that. I mean, if these were highlighted for you, you'd say, okay, we're just over 3,000 and above, those are floods, so you might be able to make that prediction. But if those weren't highlighted, what would you do? Would you say, oh, anything over this one looks like it'd probably be a flood, or who knows? So frequency distribution table, okay? Again, I'll come back to how we choose this. No big deal. Any questions on that? All right. This is important, though. I guess we should make note of this. If you had a measurement of exactly 2,000 cubic meters per second, the question that you might have is, which category should it go in? This one or this one? And as long as you keep it consistent, I don't think it really matters. But just so that we are consistent, and this textbook tells us what they do, the 2,000 would always go in as the upper limit here. So it says if you had a 2,000, it would be included in this interval, not this one. Okay. The other question might be then, why is 2,000 even mentioned twice there? Which is a good question. If they put 2,001 here to 2,500, I think that would be a good idea. Except for the fact if we actually had a measurement that was 2,000.5, right? Then we're in trouble, because 2,000.5 then wouldn't exist. Where would we put that? So this is what it means, anything above 2,000. So the upper limit would be included. Okay? Does that make sense? I know this is terribly exciting. Thank you for staying awake. Appreciate it. All right, so here's what was mentioned. 3 floods here, 1 flood there. So we could make a judgment of anything over 3,000 cubic meters per second might be trouble. All right. This is a, I think this is a, we're creating a histogram now. Okay, so let's just fast forward to this. This is, you might have called this a bar graph in years past. You should have heard the term histogram, and you should have that explained or defined in your notes already. So the histogram is basically taking that frequency distribution, that tally chart, and making a bar graph out of it. So it's a little bit more visual. Okay? And again, we can kind of see some visual things here. Like there were lots of years that were represented by this flow rate between 15 and 1950, let's say. And they did different intervals here as well. Okay? So that's a histogram. You'd have your 2 units, one on the bottom, one on the side, and then you would draw these bars that would represent the frequency. Okay, so histogram. All right. This one is the frequency polygon. So this is a line graph. The other one was like a bar graph. You might have heard that before. This is a line graph. And really, instead of the bars going across the whole interval, they just have a sort of a point, one point that would represent the data there. Okay, so this one is nicer to look at because you can kind of see the trend, up, down, whatever. You can see that there were some high years here, but it dropped considerably. There's not a lot of number of years here that have this flow rate. So this would be, I guess, number of years and the flow rate. So there's more years that have this kind of common flow rate here, and not very many years that have these flow rates. So those are the 3 different ways to sort of represent that data. All right, just one more examples here. Here's some histograms here. And here's some just explanation of the Richter scale. So the Richter scale is basically a measurement of how intense earthquakes are. So when you hear on the news of an earthquake of magnitude 7.5 or whatever on the Richter scale, you know that that's pretty intense. Anything over 7.9 is very destructive. Okay. So less than 3, it's not really felt. A passing truck, okay, like a passing big truck, a big semi or something like that, that would sort of, you'd kind of feel a slight rumble in your house, or that would somewhere be about 3 to 4. Considerable damage to weak buildings up to the 5 range, and so on. Okay. I'm just going to go back, I think, to that first example real quick, and I'm going to talk about these intervals. Okay, so I said there is a way that you could figure out what these intervals are, and sometimes in the question tells you how many intervals to make, and sometimes you have to decide that. So let's see, this one here, determine the water flow rate that's associated with serious flood by creating a frequency distribution. Okay, so that's just the question. You get to choose how many intervals you would make. And I think it looks like in this person, they decided to use 10 equally sized intervals. So based on the data, it doesn't really matter. The more intervals, I guess, the more information, specific information you can get out of there. So in this, the person decided to do 10 intervals. Okay, so how do you decide the size of each interval? Right here. This is what you do. You take a look at the range of your data, and so the largest number that you saw was 4587, the smallest was 159. So you find out the range, subtract those, and you get the range here, and then with this number, you divide it by how many intervals that you want. And so in this case, you divide it by 10, you get this number right here. Now, you don't want intervals of 442.8 exactly. You want to round that up. Okay, and always round up so that you have some larger intervals. So they could have done 450 pretty easily, right? But just for being simple, they went up to 500. Okay, so that's how you decide on your intervals. That's also sort of how you decide how to, if you're drawing a graph on graph paper, right? how you decide what each unit is on the graph paper. You do the same sort of thing. You look at your range, look at how many intervals you want, and you do the division. Okay? Now, I think that's all I'm going to do for the sort of the teaching on this. As far as the examples, I've walked you through it. I would like you to kind of get started and do some of this on your own. So I'm going to give you your assignment, and number 3 I think will be the first one on your assignment here, so let me get to that. So a chance to practice what we've been learning here. That's number 1. Let's go to number 3. Okay. So number 3 says, and this is what I want you to start with, a cherry orchard has 30 trees with these heights given in inches. Make a frequency table, so that's that tally chart table, with 6 intervals to organize the heights. Then construct a histogram of the data, so that's now a bar graph from there. And then third question here is which range of heights occur most frequently. Okay, so I'll let you answer those. So again, you do not have to organize the data from least to greatest here if you're making a frequency table. It does that for you. Okay, so first of all, you need to find the range, right, and divide it by 6 and round up, and that's going to be the interval for each row of your table. Okay, so go ahead and get started on that, and let me know if you have any questions. Okay, so here's the assignment that you can do, 3, 4, and 6. And I'll show you those here, 3, 4, and 6.